Welcome to the channel All Competitions. In the last lecture, we have seen what is meant by proof, different types of proof, and out of that, we have seen what is meant by proof by construction and proof by contradiction. In today's lecture, we are going to see the example of proof by contrapositive. So let us, as we know that in the case of conditional statement, P tends to Q, which is same as negation Q tends to negation P. So that is a contrapositive property. Okay, means if P tends to Q is there, then negation Q tends to negation P. So let us take first statement P, which containing X is even number. X is even number. And let us take here Q is another statement which containing X square is even number. So as we know that if one number is given to you and if it is an even number, then square of that number is also even. That is the proof by construction method. Already we know that. Okay. So the resultant of this one means if I take P as an even number and also Q also have as an even number, then P conditional Q which will be true. What it contains? If X is an even number, then X square is also even number. Fine. So that is the, you can say, number one. Now, if I go for negation Q tends to negation P, what will be happen? I'll be write here simply negation Q will be equals to X square is an odd number. Or you can say X square is not even number. X square is odd number by X is not even number. You can see here Q which gives here X square is a even number and I have taken here negation Q that will be gives X square is not even number. That's why you can say X square is an odd number. Then the negation P will gives me X is not even number. So I can write here negation P which is equals to X is not even means odd number. So if I take here negation Q tends to negation P, then it will be simply if X square is not even number, then X is not even number. That is also true. Or you can simply say that if X square is odd number, then X is also odd number, and this is true as per the construction method. So this one is also true. You can mention this as a equation number second. So by using equation number 1 and equation number 2, we have proved this statement. Okay, so that is the proof by contrapositive property. Okay, so let us take another example of contrapositive. If A, B, C are non-negative numbers, then for C is equals to A multiply B, A is less than or equal to root of C, or B is less than or equal to root C. That we have to prove by using contrapositive property. So let us see how we are going to prove this. So as I mentioned here, C is equals to A multiplies B. Let us say this as a equation number 1. And what they have given, ABC are non-negative numbers. Okay, so we have to discuss for only positive numbers. Okay, so what they have given, A less than or equals to root of C, or B is less than or equals to again root C. That is true, we know that this one is true, but we have to show that by using contrapositive property. Okay, so let us, this one is take as not true. This one is take as not true. That is equation number 2. So you can mention here not A less than or equals to root C, or B is less than or equals to root C. So simply how to represent this? Negation of A less than or equals to root C, or instead of this or, I will take here this sign or this notation, B less than or equals to root C. Okay, so this is your equation number 3. What is the next with respect to this? You can see here it containing negation of one term, and in between these two statement formulas it having ORing. Okay, so I will take here De Morgan's law. So if I go for De Morgan's law, then what will be happen? This will become negation of A less than or equals to root C. Okay, and negation of B less than or equals to root C. So that will be the formula we got after applying De Morgan's law on equation number 3. Let us say this as a equation number 4. Now what we have to do, we have to take this one, this formula. Here mentioned negation of A is less than or equals to root of C. So what is the meaning of this? You can mention here A is greater than root C. Okay, A is greater than root C, because negation of A less than or equals to root C. This end will be as it is, and here B is greater than root C. Okay, so let us say this as a formula number 5. So as we know that we are taking the multiplication of A and B, and which is equals to C. Okay, so if you go here, then what will be happen? See, A is greater than root C, B is also greater than root C. So what will be the result? A multiplies B will be greater than root C into root C. So you can say A multiplies B greater than C. So say this one as a formula number 6. But initially we having C is equals to A star B, and here we got A star B is greater than C. Okay, means from equation 1 and 6, equation 1 and 6, it's not true. What is not true? Equation, whatever we have taken here, this one is not true. Equation 3 is not true. Hence, we will go for the original equation, that is equation number 2. So, we can say that A is less than or equals to root C, or B is less than or equals to root C. Okay, so that is the proof by contrapositive. Okay, so that's all about proof by using contrapositive method. I hope that you got this idea. Thank you for watching this video.